welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. I'm Alice, education lead at ZKM. Today I'm joined here with co-host Pavel, who's DevRel lead at ZKM, and our very special guests, Adam and Antoni, the co-founders of Aleph Zero. So thank you so much for being here, both of you. We're very excited to have you. Just wondering if we could first start off with some introductions of yourselves. So both you, Adam and Antoni, your stories on how you got involved in the Web3 space and specifically focused on ZK.
Okay, so maybe I'll start. So I'm interested in blockchain for quite a while. I've started with mining Bitcoin 11 years ago. And back then it was just a hobby. It became a full-time thing with start of Aleph Zero, which was already 6 years ago. And back then we've been interested mostly in consensus protocols. Like it seems to us at least that this was the time in the space where people wanted mostly things to be faster. So my background is pure mathematics. I did PhD in math, and hence I got interested in like designing deep down how the consensus thing works. And somewhere down the road, I think it was already maybe 3 years ago, we realized that speed is not enough, that we do need to offer another USP that is more, future, let's say, proof than just speed. Like eventually there will be a lot of reasonably fast blockchains. So back then I already did have some background in ZK and some, let's say, non-professional interest. So back then we started to gather the team of cryptographers, and actually, we started a university course, teaching university course on privacy. So we then hired a few of our students, and that's how we assembled a team which is currently working on privacy in Aleph Zero.
Yeah, and thank you for having us, Alice and Pavel. It's a pleasure to be here. My background is more on the business and marketing side. So I was always since like I was 19 probably, I was involved in tech startups, scale ups, everything that had to do with tech and trying to create and translate the technology into the market needs and the other way around also. So how we started was essentially Adam had this idea for the consensus protocol, and then with two of our co-founders, we kind of got together and divided the responsibilities the best we could. And I was handling the entire essentially business side together with Matt, as well as our marketing, branding, comms, product front ends to a degree as well. And that was pretty much it. So today I'm still primarily doing that, and happy to have the opportunity.
Yeah, great. And it's very incredible to hear both of your very diverse experiences. So Adam, you came from a background in academia, and Antoni, you had a lot of experience on the business and marketing side with different startups. So really good to see like those different experiences converge, and then utilizing those experiences for what you're building today. Just going into that, I'm wondering if you can speak about what the original vision was behind Aleph Zero when you guys first founded it, and how it evolved over time. And maybe you can also speak about how Aleph Zero fits into the broader ZK or privacy landscape.
So I think when we started, the landscape looked a bit different. In particular, it was not so ETH-centric as it is now. So it was definitely not clear that Ethereum and the ecosystem around it will become basically almost the entire thing. Right now, it seems, at least to me, that that the world becoming increasingly more and more EVM centric and generally Ethereum centric. So back then we wanted to give people an alternative. We've seen it as kind of a race when it was a speed and throughput race that we entered back then. At least that's how it looked like. So almost entirety of our work was focusing on backend, on making consensus faster, on making node connections faster, and things like that. We started with non-EVM blockchain. Well, also because the thinking back then was that, well, okay, so there is EVM and Solidity, which is imperfect, and it's still these are still early days. So it seems natural that eventually some alternative will come into play, into game, and eventually win. Right now, I think the landscape looks a bit different. That's why we launched our EVM version of Aleph Zero, so we can offer our features to the right now much broader audience of EVM compatible or like, let's say, EVM users, as it's also becoming increasingly more interchain. So that's our current vision. So from the vision where we wanted to offer just an alternative blockchain in the world of many blockchains that raced to become the fastest and the most used. Right now we see it more like an interchain world of mostly EVM chains, where we want to be just a hub to offer a single utility for all of these chains, and this utility being privacy, of course.
Yeah,
Which
and
adds.
but I think the privacy was also like in the center of the value proposition since the early days, because like also we started with consensus, then we've integrated it with the substrate stack, and we had this idea to embed privacy on the L1. Like the challenge that we were facing was primarily distribution, right? So you kind of, if it's a new tech stack, then you have to get it integrated everywhere, and that's the most challenging part. But still, with the EVM compatibility, we're kind of fixing that and making all the external integrations faster. While, as I mentioned, kind of adding this utility of being able to just have Aleph Zero as the go-to privacy, hopefully the go-to privacy solution for the space.
Yeah, I got it. And then just on the general topic relating to privacy, I'm wondering if you could talk about like the status quo and how we deal with privacy today in both the Web3 and non-Web3 settings, and why you see ZK as an optimal privacy design, and maybe you could also from there discuss about some of the challenges with other solutions.
So I think we're in very early days when it comes to privacy. We don't actually have products with a proper user, or we almost don't have products with proper user experience which are targeting regular users. There are already well-known products that have been targeting pro users, but when it comes to targeting the broader audience of general blockchain users, I think these are very early days. And also there is currently mainly one use case for blockchain privacy. This is anonymizing your tokens, anonymizing user tokens. And this is a very important use case, maybe the key use case, like the key thing that is lacking on the blockchains, because like contrary to I think public perception, blockchains are not anonymous and do not offer privacy by default. So fixing this flaw seems a very natural thing to do. Although, like even putting aside for a moment the issue of being compliant and countering money laundering, I think there will be a time in this conversation to return to it. The big problem is the user experience, and also the thing how people tend to think about this anonymizing aspect. So I think still the prevalent narrative or prevalent way to think about it is that we want to have a special place where we can mix our tokens, so when we take them out, they are anonymized and we break some linkability. And this is true that the systems works this way, although in my opinion, in our opinion, this is not the perfect product where you need to constantly think about how anonymous or linkable are your tokens and the current moment, and whether you should do this special thing again at this point, or maybe they're anonymous enough. So like how we like to think about it is that this is a thing which should naturally be embedded into wallets. So user have a wallet which just by default offers this anonymity feature. So basically speaking slightly more technically, a wallet where tokens by default are kept in the privacy pool. This is something that, I mean, it's not absolutely unseen. This is what some of the other projects are doing, although when it comes to the ones which are deployed and actually have users, there is just like maybe 2 of them. So yeah, very, very early days, still a lot to do, in my opinion, maybe when it comes to user experience. Big part of user experience are the things which are inherently harder for private wallets than for natural wallets. For example, the fact that you need to compute the proofs, which is, well, takes a lot of time usually. So this is one obstacle. Or maybe, okay, let's leave it like that for this general answer. I think we'll return back to the particular obstacles that we need to overcome to actually offer a proper UX.
Yeah, and in terms of some of those obstacles you mentioned about the compliance challenge and say on the topic of preventing bad actors from abusing privacy or abusing the fact that there's anonymity, I'm wondering if you can maybe speak about some of the like regulatory challenges in that privacy landscape, or like the current challenges that exist with achieving that compliance. So balancing like the need for privacy, but then also being compliant, and maybe some of the methods that Aleph Zero has taken on to try to address that trade-off.
So for now, we're trying to play very safe. I mean, we're keeping this part very modular with the hope that with time we will employ more mechanism and give users the choice. Although for now, we're focusing on a pretty drastic countering of a main fraud pattern that is seen. And this fraud pattern being as follows. So there is, like, usually it happens like that. There is some major hack, maybe like a bridges tends to be hacked often, or some other major crypto hack. So like it is publicly seen and everyone knows which accounts have been involved with the hack and where are the funds. And then there is they are traceable until they disappear in some anonymity solution. So like there is a single or like several deposits to a privacy pool, and then the funds are essentially, well, gone. I mean, it's impossible by design. It's impossible to trace them any further. So there are several ways to counter it. Like there is a hope of there is this popular concept of proofs of innocence. So the idea here would be that there is some kind of like a list of compromised deposits, and then users doing the withdrawals can prove that, well, these funds do not originate from any of these deposits. Like this solution is very problematic, and in my opinion, it's not so hard to circumvent it. For example, by making internal private transactions inside of the solution. So what we're doing is actually a bit more aggressive, in the sense that in each deposit, I mean, we are keeping users to we are assigning users with persistent ID inside of the system. This ID is private at all times, and but all of the actions of the user are cryptographically marked with this ID. And then we have a process which allows, given a malicious deposit, to reveal the ID associated with this fraudulent deposit, and also, in the consequence, to reveal all other transactions associated with this ID. So Currently, this process is based on party which is usually doing KYC. That does not mean that we require KYC for every user. It's just that parties doing KYC usually do have this legal process of answering law enforcement and assessing the actual risk. The next step here will be the council of such providers. So there will be like a DAO that will be deciding about which deposits are and which are not fraudulent. And then, well, we are looking at other projects, like, for example, Privacy Pulse, which is currently one of the popular projects, and we're still looking for other approaches. Although, yeah, we decided to play rather conservatively as we really don't want to see bad actors in our system.
No, but there's also maybe one more thing to add, because there is, this notion that, especially in the European Union, it might be possible that the regulators will essentially enforce the DeFi space to use KYC in one way or another. Whether that's right or not, we could spend probably the next 3 days debating, or whether that actually protects from anything. But if, under the assumption that KYC eventually might be needed, we have established a relationship with the IDOS network. It's a relatively new use case that is being built by a team behind Fractal. And it's essentially a consortium of various chains, including and companies, including Circle, for instance, and with the end goal of making your verified credentials interoperable, so that it kind of with this assumption that we will have to use KYC more and more, or like an identity verification for various on-chain activities, then how do you make it more seamless for the end users? And the idea is that you would have essentially first user stored credentials. So once you do verify your credentials, you own them. You don't give them away to to a KYC provider, essentially. And then for every use case integrated into the IDOS, you can essentially share your credentials, and that would be an equivalent of you going through yet another KYC process.
And you briefly touched on the proof of innocence, and you mentioned how the proof of innocence can be manipulated, or it's not the main solution that you're going after. Can you describe what like how proof of innocence can, I guess, negatively impact, or someone can abuse that system of proof?
Not to say that it can negatively impact. I mean, definitely a system with proofs of innocence is better than the system without them. It's just we don't see it as a bulletproof solution. And there are, I think, two main reasons for that. One more technical and one more technical in the sense that it's related to the state of the ZK right now, and the other more conceptual. So the more technical one is that the system generally is based on the premise that users will be met with some kind of a delay. So when they do the deposit, there needs to be some delay. They need to wait before they do withdrawal. So this list of fraudulent deposits can be updated fast enough, so they are not actually able to do the withdrawal. So the system, the delays I've been seeing are around 1 hour, which is like the entire orders of magnitude shorter than how fast the OFAC list gets updated. So that's one of the problems. The other is that there are certain attacks, like for example, this list of fraudulent addresses. This works okay if this list has 5 addresses. If this list has 5,000 addresses, this proofs that users need to generate become quite big. And even more so, the problem is that, like, while you can compute this proof once and use it for all of your withdrawals as a general user, unfortunately, whenever this list gets updated, you need to recompute the entire thing. So, like, there is this kind of a griefing attack where, like, either you can update this. I mean, if you are a hacker and you want to annoy someone, you have some fraudulent funds, you can basically do one deposit every half an hour. The list will get updated every half an hour, and all the users of the entire system will have to recompute this, well, relatively major proof, I'd say. And also, it doesn't behave very well with thousands or like tens of thousands of fraudulent deposits. So that's one of the things. But this is related to the state of ZK, and I guess this one can be actually circumvented within a couple of years, maybe. I mean, we get faster proof systems like every couple of months, maybe now. The other thing is that if you don't have, I mean, if you have a system which allows internal private transfers, then it gets even more problematic because, well, I can always claim that I'm a user and I got all my funds via private transfer. And, well, honestly, I don't know. I was buying something from the guy and he looked legitimate, but honestly, I don't know where he got his funds from. And that can be my claim, and this is unverifiable. But what actually may have happened is me having two accounts, one which just got deposit from the funds I've stolen from a breach hack, and the other like just receiving the private transfer from the first one. So this is more of a conceptual problem where it seems that either there needs to be some major constraints on internal transfers, like you need to actually assign this proof of innocence even for internal transfers and do this stuff with delay even for internal transfers. So like this seems to be restricting the user experience pretty much actually. Or well, otherwise, I don't know actually how would you solve it otherwise. It seems that the system would need to have quite a lot of delays.
Got it. So an impact towards the user experience as well as the internal transfers.
What I wanted to say is I don't claim that this is a proof of impossibility of this kind of solutions. I just think that they are not as simple to deploy as it may seem at the first glance. So that's why we decided to go a different direction.
Mhm. Yeah, prioritizing the user experience, prioritizing the state of ZK today, also very important considerations. I know that we spoke recently with the Tyco CTO or Gwyneth, and they're using a multitude of different solutions and not just relying exclusively on ZK for its in the entire stack. So I think that also goes to that philosophy of not relying on a single tool that can potentially break, and then also prioritizing the user experience through the entire flow. And so essentially you want to meet the needs of everyone that's using your product and making sure that the value proposition is still there without the big overhead of usage. Thank you for clarifying.
Yeah, and we're definitely, as Pavel said, seeing a general trend of just adding different security layers or security mechanisms, not just ZK. And it's great to see that you guys are prioritizing the user experience. It's, as you mentioned, still a very big challenge in both the privacy and general ZK landscapes. And you mentioned previously, or Antoni at least, about like making verified credentials interoperable, like avoiding delays and other kinds of factors. I'm wondering if you could speak a little bit more about maybe the specific pain points that you see users experience and the factors that you believe should be prioritized when dealing with the user experience, or if there's any other kinds of trade-offs in prioritizing the user experience that maybe some other factors may not be as focused as much. I'm just curious to hear about like the process that you guys take in trying to make the user experience as like seamless and as optimized as possible.
Yeah.
So, I'm sorry.
Oh, okay. I'll just maybe start quickly. Like the overarching principle is just make it as humanly simple as possible. You know, we all kind of have our apps that we use and love because they are simple. We choose the devices that we feel, let's say, we understand them the best, right? And the current state of privacy wallets, for instance, is that they either crash or they take too long or the interface is super complex and like we understand where it's coming from in the sense that it's just on the tech side it's difficult and you have to figure out how to make it usable on the front end also. But if there are two things that we want to be known for as a zero, that would be essentially this UX, which we understand by a proper combination of essentially front-end design, but also the back-end design, so that you have to design the back-end in a way that is easily integratable on the front end, and like the visual identity is you know something that just it's a cherry on top, honestly, and all the interfaces. The overall effect or the overall take that we want the users to have after they've interacted with the product is that they actually enjoyed using it, and doesn't matter if it's private, non-private. It's just our North Star. Like the first, you know, after the mainnet deployment, we were very, very happy because you could send like coins from wallet to wallet with instant instant finality, in the sense that you've sent them from one wallet and they appeared essentially at the same time on the recipient's wallet. And with this notion of speed that Adam mentioned at the beginning, we also want to apply that to the ZK operations, or like privacy. So how fast can you actually shield your tokens? And then is the interface understandable enough and simple enough so that if you just give it to somebody who is completely out of context, they will know what to do? And this is something that is still lacking in Web3. It's way better now, or crypto. It's way better now than it was, you know, like in 2018, where we, as an industry, kept telling people that the best way to store your seed phrase was on a piece of paper in 5 different locations. But at the same time, we were pushing for, hey, let's go for mass adoption, right? So it's just something that we think is extremely important and still underappreciated. And we use the arguments of security and decentralization to avoid kind of diving into this. And we're not talking about like having entirely centralized solutions, because that's the easiest way to make something simple on the front end. But we think it's still doable, and hope that this first testnet Shielder deployment is going to show that, well, some progress in the area can be made.
Yeah, I can offer some more, slightly more technical perspective when it comes to these UX problems. So, like ordered from the least technical to the most technical, all being somewhat technical, is that the first problem is the speed, as Antonis said. The second problem is interaction with dApps, and the third problem is data transfer. So, speed is kind of obvious. Like, in order to do anything private, you need to compute ZK proof. And what's even worse, you need to compute it on user's device, because you don't want to store the secrets anywhere else but the user's device. And what's even worse, like, you don't actually want users to have a desktop app related to this particular solution. Most probably you want to have a mobile app and a browser extension, because like this is kind of a default stack for how people use crypto products. So unfortunately, when it comes to browser extensions, like I don't want to go too much into the details, but it is significantly harder to employ the entire computational resources of the computer from the browser extension than from the desktop app. So like this is first of the challenges. I think the ZK space is at the stage where this challenge can be already crossed out. I mean, we run benchmarks with few hundred of users, and like exactly half of them had a proving time lower than 1 second on their machines. So like this seems okay. We consider it as a good user experience. The other one, the interaction with dApps, is unfortunately more conceptual and much harder to totally circumvent. So to explain the problem, like how users usually interact with dApps is like, let's say that user connects to, well, I don't know, Uniswap using MetaMask, let's say. So how it usually goes, like the flow is that the user click connect, chooses the wallet, then there is a Uniswap frontend where user can choose a token, and the Uniswap frontend already knows what token amounts are in the wallet, so can even use, I don't remember whether Uniswap have a slider, but I think it does. So user can even use the slider to trade half of the entire amount that's available, and then click send. And basically everything is smooth because the front end have all the information about what's on the account. So now, like, we do private accounts. So if we, like, the concept of connecting the private account to Uniswap wallet seems complex because Uniswap will not know what's in the account. So it's impossible to have this kind of front-end interaction that people are used to. So there are two ways around it. You can either release some kind of SDK for the dApps with the hope that they will use it to allow users of private wallets to actually use their product. So this kind of SDK would basically allow to locally render the frontend on client side and basically use the same sliders. But this is very complex because basically you need to convince entire world to use your SDK. And there is another thing to rethink the flow that the user is engaging. So we are currently on the second. We're trying to do the second option. We're doing the second option, and our current flow should require either 1 or 2 more clicks from the users, which is not so bad. So like when you connect to well, let's use this Uniswap as an example, the default option that the wallet will propose is to use the newly generated one-time account. Then user, like, so this is the same click that you would normally do by connecting your general account. Then you need to unfortunately top up this account with appropriate amount of tokens from your shielded account, and then the interaction proceeds as it would usually do. So like this is somewhat more complex than that, because we in the wallet will remember what one-time accounts have been used with which of the apps. So when user logs into the app that it has been using before, there will be an option of generating the new one-time account or using one of the old ones. So like this is necessary because, for example, there may be some LP tokens on some of these old one-time accounts, or like oftentimes another interaction from the same account is essential. So this is the second obstacle, and like this can be circumvented, but to some extent. I mean, this kind of wallet will require more attention from the user and more clicks, although just a little bit. And the third thing is related to data transfer. So unfortunately, all the current privacy designs require users to download quite a lot of information from the blockchain, or to reveal to some provider which information user actually needs. So like there is this kind of trade-off. I can either download everything, or I can tell this provider like what's my ID and ask him to send me only the things which are related to me. And there are various ways to go about it. Currently, what we're doing is called fuzzy message detection. So this is a particular cryptographic protocol which allows the user to choose the trade-off. I mean, so user can download only what it actually needs and reveal basically everything to the provider, or can like download significantly more that it actually needs, but not entire blockchain, and reveal just a little bit to the provider. So like, yes, this is also somehow circumvent. Also, I'd like to point out here that even revealing absolutely everything to the provider is significantly better than not using the private wallet, because like, at least for me, when I'm not hiding from the government, I basically just don't want everyone to see like what I'm investing in and like generally what I'm doing. The situation where there is one party in the world, which is basically a professional RPC provider, that theoretically has my transaction history, this is definitely better than like all my neighbors or friends and enemies seeing my transaction history.
I like the multi-layered approach. Essentially, you're focusing on the simplicity, the functionality, and the speed of processing. So it's essentially the pillars of essentially a usable solution where anybody can come in. And of course, keeping in mind the trade-offs and the thought process is considered, picking that best of the three if in terms of the solution. I think it definitely sounds like a lot of thought went into
Yeah,
your
like
current design.
currently, I think we spend more time on designing user flows than on actually thinking about cryptography, because like this is the unsolved problem. I mean, privacy, like even conceptually, is tricky because it's enough to reveal something once. Like if you reveal something once, it's being revealed forever. So like, for example, if you are using one-time accounts and you send the transaction between them only once, like they are connected forever. So like the same thing, for example, with if you deposit and withdraw exactly the same amount to the privacy pool, it's gonna be linked. So like designs that will be enforcing this kind of proper interaction patterns, like this is, I think, was the hardest unsolved problem in blockchain anonymity, and not like the ZK problems. Unfortunately, like me being mathematician, I would prefer like the other to be more important. But yeah, it seems that like these ones are somewhat solved already.
But you
Yeah,
still
got it.
optimize the ZK and Halo too. So it's, I would say it's literally the two of the biggest challenges right now still.
And I really like, Adam, the way that you kind of split the problem into three different categories that you're trying to address. So one with speed, and the other with interaction with the dApps, and then also with data transfer. So it's not just a one-dimensional problem with just like ease of use or like wanting to optimize to just like have the user just click a few buttons, but it's really a very, like as Pavel mentioned, a very multi-dimensional problem. And I really like
Actually,
the way
there
that
is
you
a
laid it
fourth
out.
thing here. Like, what's also a terrible UX is when you are using anonymity solution and then Chainalysis is red flagging all the withdrawals that you're doing. That's terrible UX. Like, you're gonna have very hard time depositing your funds into any reasonable checks. Like, so, like, actually, compliance and fraud protection also, you can think about it as part of user experience, because it's not only about fighting the bad guys. It's actually about helping the good guys to not be falsely accused of bad activities.
Yeah, exactly. So there's trade-offs, and like even in that scenario as well, with adopting these like fraud protection mechanisms, in trying to protect those who may become victims to those bad actors. But what if they themselves are like accused as well, which also interferes with that user experience. So really great that you mentioned that trade-off as well. Wondering if we could segue into the applications and use cases side. So I know that Aleph Zero has many different kinds of projects that are currently in the ecosystem. So I'm wondering if you can talk about the types of projects that you see as ideal for and that can benefit from the ecosystem, and maybe scoping out a bit, if you could talk about some like privacy-focused applications or just general ZK use cases that you see have a lot of potential in and you're personally excited about?
Okay, I can start with two of them. So the first one is essentially anonymous voting or anonymous governance. This is something that is very Web3 native. We have the privacy is not on the mainnet yet, but we have a use case called Syncra. It's a team that's been with the ecosystem for a while. And we've just had a governance vote around the Aleph Zero economy, and the next subsequent ones, as we push the privacy on the mainnet, are going to be anonymous, which is going to be quite interesting because I don't think we've had any large scale deployments that do have this feature. And then Syncra's business plan is to also expand to other chains and be able to offer this feature of private voting essentially. And they also prioritize, not necessarily rebuilding your entire governance platform, but being able to use those features as simply as possible. Then, if we think about Aleph Zero as, let's call it from a high level a privacy hub, and it's here, then what kind of interfaces would you need to build for what user groups or target groups in order for them to benefit from it the most? And we have essentially, you can say, three products or sub-products or three interfaces that we work on. And the first one is a mobile app. So if that's essentially a wallet, but also a unified front end that allows you to access various different protocols from within the privacy pool, ultimately, right? Initially, it's going to be just a shielded wallet that allows you to do relatively simple shielded operations. In the end, in the industry, I think we have all the components that we need to effectively build an open source equivalent to a bank. You've got lending protocols from different ecosystems. You've got solutions like Holy Held, who we work with, where they can supply payment cards and bank accounts and all this. So still all we're missing are next level front ends, basically, whether in the mobile or on web, and it doesn't have to be exclusive to a single ecosystem. You can basically pick and choose, or let users pick and choose, or have it chosen via governance. So this is what we're working with Common Mobile. And then one more avenue, since we do a lot of work with enterprises like Deutsche Telekom, Saudi Telecom, Polish banks also. How do we get them on chain in a way where we mitigate the problem of the data being, two problems really. First, how could they use crypto in a non-custodial way, but still preserve the privacy? So that's problem number one. And typically they just use Fireblocks or custodians. But if you would, let's say, build a front end that also is suitable for their internal approval processes and is able to essentially conceal the transfer flow, then there is one company that assessed that they would save around 30% on just FX fees if they switch to stable coins for payroll, for instance. And then another thing is, can shielding or privacy help to effectively keep the data of the on-chain data of that enterprise within a single jurisdiction? Because that's the main challenge with storing it on-chain in a decentralized fashion.
So just a clarification, would the ability, so you mentioned private governance votes, and that your intent is to essentially become like a sort of, not necessarily like a bank, but essentially the same functionality as a bank. Like I don't necessarily have access to transaction data from other people using the same bank that I do. I have to essentially have access to the account. So I guess is the goal to process uh, cross-chain transactions through Aleph Zero, is essentially in a way where you have the privacy-preserving aspects localized um, to Aleph Zero, and then essentially the overall like, execution would be done on the corresponding
That's actually
layer.
the basic flow that we're thinking about both for the general user app as well as this enterprise solutions. So, like what we're targeting is, I'd say text-like experience. So, like you have just like your shielded funds, and when you want to initiate a transfer, what you do, like when when you're Binance, you usually like choose the token type, choose the chain, put the address, put the amount, and don't care about like how it's gonna end up there. So like when it comes to blockchain, of course there are bridging costs, although when it comes to layer twos like this, they are like going closer and closer to becoming negligible. So the actual the main user pattern that we want to propose is the one where there is a single privacy pool on our chain, and as we do like the optimizations for the cheaper proof verification and stuff, so the funds are residing on our chain, and this serves as a privacy hub for the general EVM ecosystem. So whenever you want to like either send a transfer to say Base, then you can just choose Base from the list of the chains, or if you want to integrate with the app on with the DApp on let's say Polygon, you go to the DApp site, and like automatically the wallet proposes to create one-time address on this particular chain.
Yeah, great. Thank you so much, Adam, for that clarification. Wondering if we could also talk a little bit about some more of the design considerations that you guys chose. We talked a little bit about this in the beginning of this episode, but wondering if you could provide us with a walkthrough of the process for some of the design choices and considerations you made. So like, for example, within Shielder, I know that you guys use the ultra-plonk proof system as opposed to Groth16, and you also chose to use KZG as well as Poseidon 2 as opposed to some other like commitment schemes and hash functions. So wondering if you could talk a little bit or like walk us through the process in choosing these specific design choices.
So the overarching principle was that we want a product that is fast and but still is somewhat flexible when it comes to the updates. I mean, our roadmap goes quite far into the future when it comes to the additional features that we're gonna be deploying. So unfortunately, Groth16 requires to run what's called a ceremony for each particular circuit that's written. So like whenever we would be adding a new privacy related feature, we would require a new ceremony, where the ceremony is basically a very complex thing, and if the ceremony fails, then basically the feature that was deemed to be private is not only not private, but actually oftentimes it's even much worse. Like oftentimes people can do things that they like mint things out of a thin air or things like that. So we definitely did not see our product as kind of a closed. We did not want to develop our product in the way where we need to know everything from the get-go about all the features that we're gonna ever want. So that's why we did not want to use Groth16. And besides that, well, the speed was the biggest factor. So we wanted to write in something that is low level, which would allow us to actually get into the level of designing a Plonk table and optimizing it. So Halo 2 seemed as a good choice. We also, I mean, we've been playing around with Halo 2 before, so that seemed a pretty natural choice. We actually had like a 2 to 3 months marathon with just optimizations of plonk tables and this low level things. And I don't think that would be possible in any of the higher level frameworks. So whether Halo 2 is the only possible? No, definitely not. It was just the fact that we knew it, and we knew that it's well maintained, and multiple projects are building upon it. So like that was also a factor to consider. We definitely didn't want to end up with something that will like that in a year we would end up as a only project building on this particular stack. That would be horrible. And yeah, Halo 2, there are multiple forks which are well maintained. Multiple major projects are using it, for example, Axiom. So yeah, that seems pretty one of the good choices. When it comes to KZG commitments, well, yeah, so they're small and they're fast, and yeah, that was pretty obvious. We didn't want to go too much into like this. I know that Starks are becoming more and more, say, popular due to two things. One is the lack of this necessary lack of a ceremony, so kind of theoretically better. We like I don't want to say it sounded I don't want it to sound bad, but we definitely prioritize like product deployment over complex solutions that would be theoretically better. Like KZG commitments, I think, are very mainstream right now, so I don't think anyone would see it as a controversial decision.
Yeah, great. And I really like how you first went off of what your biggest like priority was, which in this case was speed, and then from there working on like which different proof systems or commitment schemes can really
like
help
for
with
example,
that priority.
Just to put it into some perspective, it's not the only possible thing to optimize for. For example, another thing would be verifier time. So Halo 2 has a good verifier time and cost, although it's not the best out there. We just had a lot of discussions regarding what is more crucial here. For example, usually for ZK rollups, verifier time is like the most important thing. So in our opinion, for privacy, where proving happens on user devices, the prover time is actually more important. Like whether it's the transfer is gonna cost, I don't know, 3 or 6 cents to verify, this is less relevant than whether it's gonna take 1, 3, or 7 seconds on the prover on the client machine to prove.
Yeah, got it. And just relating to like the proving on the user side, I know that you guys recently or are currently building ZK-OS, so focusing more on client side ZK privacy. I'm wondering if you could talk a bit about how client side ZK privacy is or differs from server side privacy, and maybe some advantages and disadvantages to both approaches. So just wondering more about like the ZK-OS on that side, so the proving happening specifically on the user's end.
So I think the key consideration here is that if you're designing a system with server-side proving, you can basically pick and choose the absolutely best configuration of the server that is going to be doing the proving. And also the prover time is not that relevant. You can rent a like monster machine on some cloud provider with just the specs that are optimized for proving. When you think about client-side proving, you need to support like very broad magnitude of different devices, like Android phones, iPhones, like various desktop devices, and like they differ, like various browsers, for example, as well, perhaps, and like these things differ very much because they are optimized for different things. Like what usually happens here is that you what you are actually doing is you're doing the proving in WASM, in WebAssembly. So like there are often claims that WASM computation is very close to native. I've seen this claim on many pages related to WASM smart contracts, for example, and things like that. So if someone tells you that, don't believe it. I mean, like, this is sometimes true. This is not true for cryptography. For cryptography, it's substantially slower. What's more, like the client-side proving, as I mentioned before, we do not really have the luxury of having a desktop app. I mean, we don't want. This would be a major obstacle. I don't think too many users are interacting with crypto from desktop apps. Like, it would be definitely the easiest from the developer perspective. From the client perspective, that would be definitely annoying. It's not the current. I mean, it's not the user flow that people are accustomed with. So the browser extension seems to be the only way to go, actually, next to the web app. But like, web apps are kind of worse because the flow of connecting a web app to another app is usually a bit clunky. You need to copy paste some cryptographic things. That seems weird for users. So when it comes to browser extensions, this is maybe I just give a glimpse into the technicalities just to give a taste. So unfortunately, it used to be possible to run multi-threading computation in browser extensions. The solution was called Web Workers until I think a year ago. It was blocked from major browsers due to security considerations. And now there is this new thingy, which is called a side panel. So like multiple wallets, for example, Uniswap wallet is already transitioning to side panel. And like, it has several upsides over regular browser extensions. One is the major upside from our perspective is that it does offer multi-threading capabilities. So fast proving is possible only with multi-threading. Without it, we would have probably 6 seconds instead of 1. So that's why we focused on the side panel. The other thing is the side panel is more persistent than the extension itself. So extension has this annoying feature when whenever it's open, it can keep some data, but whenever user clicks something on the site, it closes and it resets the entire session. So like, from the perspective of this privacy flow that I mentioned before, where a single time account is generated in the wallet, and then user tops up this account just specifically to interact with this app, and maybe does something in the app and then wants to top up this thing again. Like, the persistency of side panel seems to be like I don't know, holy grail. I mean, that's definitely the thing that would be needed here. So yeah, fortunately, we're living in times where side panels are becoming more and more popular. So these kinds of user flows are actually becoming possible. I think the side panels is a feature which is less than a year old. So yeah, this is also maybe surprising that this non-ZK related innovation changes so much when it comes to privacy wallet, but I think it does, and maybe it's even more important than the actual speed-ups of proof systems. The fact that these side panels are changing the game when it comes to user flows in crypto.
Yeah, really great to hear about how we have kind of these new developments coming up. Like, the side panels are still relatively new, but still something that could really significantly help with the user flow. So really exciting to see all of these developments happening now. I think we're living in the best age as of now. There's still a lot of work to be done, clearly, but lots of opportunities, which I find is very exciting.
Also, just a quick follow-up question. You mentioned support for mobile-based devices, so like Android and such. Do you see mobile devices being impactful like as a priority? I notice I say this because typically a lot of crypto apps are built with the desktop extension in mind. But just curious to get your thoughts on this type of support for alternative
So
We,
devices.
we fight about this
yeah,
for the
constant
last
struggle.
year, I think.
So I'm
So
definitely for browser extension first. Antoni is definitely a proponent of mobile first approach. That like start with your agreements.
no, I think it depends on the end user, right? Because if you're a hardcore trader or if you're a more institutional, like you're not gonna move millions on your phone while on the go. But if we are talking about building, let's say, and we we call this movement, I guess, OpenFi, and this is something that we're doing with IDOS. There's some also Gnosis involved, and some other teams from Ethereum. Then mobile is a must, because like we're as human beings, we're naturally drawn to what's most convenient most of the time, right? And if we can simply use our phones for all the typical operations, then we will. There's this new index of sorts that people make fun of, and how do you know that good times are back is when the Coinbase app is going higher up the rankings in App Store, right? And I think there is a reason for that. Like, people just prefer convenience. Mobile is convenient. Everyone has it. And right now we can generate the benchmarks on Androids from the browser. You can go to thatfast.alephzero.org and then you can just run the benchmark yourself. We cannot do that on iOS yet because it requires an app. It has to have its own environment.
Oh, we can right
Um,
now. Sorry, just to
oh, we can
interrupt.
already.
You need
Okay,
to update to iOS 18, but since iOS 18, we're able to do that as well.
that's awesome. But so yeah, so for both, that's even better. But I definitely agree that power users are gonna stick to desktop. Although, like in my case, I just essentially use mobile for most of the operations, like browser, and then like a Uniswap wallet or MetaMask or anything like that. It's just faster.
Right. So, yeah, everyone has a smartphone. Also, everyone has a desktop device, or almost everyone. So, yeah, I see it more in a way that smartphone. I mean, what differs are the user flows, as usually, and smartphones usually are. I see it as a tool for more casual approach. I mean, you can like it's easy and fast to do a regular crypto transfer. So I think this is better for this kind of usage. I personally find it more clunky when it comes to interacting with dApps that are like just regular dApps, unless they are somehow integrated into the wallet. So, like, yes, mobiles offer generally better user experience for much more narrow scope of the things that can be done. So, I would see extension as something for maybe more pro users, like more regular users, and mobile to someone who would like to just try it out. But yeah, definitely, this is. I think it's important to support both. And fortunately, with WASM, it's not that hard. I mean, of course, like the front end's work is separate, but the surprisingly big part of backend can be the same. That's why we're approaching both.
Yeah. Hence this idea of like, this like core privacy features and then different front ends.
Yeah,
And that
got it. Good to hear.
separation, I like it. Sorry, continue, Alice.
Yeah, no worries. I was just gonna say, like good to hear to see the kind of scenarios in which perhaps like the mobile would be more convenient versus like browser extension, or maybe the types of users as well. Like you mentioned, Adam, maybe the regular users would have better time with the browser extension, whereas those who are just looking for something, maybe something more easy, more convenient, the mobile could be a good option for that. So good to see that differentiation. Wondering if we could also talk about, on the topic of Aleph Zero achieving, at least for the proving times, sub 1 second proving. which I think is really exciting. I'm wondering if you guys could talk a bit about the process you took for achieving that, evaluating it. So maybe some of the optimizations you decided to do, some like specific setups for the benchmarks, just like your process for achieving that.
So I don't know how I mean, like, to be on the similar technical level to the rest of the conversation, I like fly over some of the details, but yeah, we actually ran this project properly, which means that we started with having a benchmarking suite, so to have like integrate with GitHub, a tool where, like, whenever we do new PR, like, it automatically goes through the tests and reports the times on not only the final time of approving, but also partial times on several aspects of approving. The one which is called MSM, multi-scalar multiplication, is usually the like one of the bottlenecks. So we started with zero multi-threading and just the basic circuit, and I think the time was something around 10 seconds back then, although I'm not entirely sure. I mean, we have a blog post with like specific details. I just don't remember the time. It was already a couple of months ago. So then it took a significant amount of time to figure out how to actually properly run multi-threading in the browser. So the side panel thing that was definitely not obvious to us, that if we transition from the normal extension to side panel, we're gonna gain the possibility of running multi-threading. So that was one of the major findings. Then we started with Poseidon, with general Poseidon, like Poseidon 1. I mean, it's not called 1, it's just called Poseidon, but we started with Poseidon hashing function. We read the paper about Poseidon 2, which claimed that it should provide a speed up of 30 to 40%. And well, since hashing is actually the definitely biggest bottleneck, we decided to implement Poseidon 2. And yes, we succeeded actually, and it did. After several optimization in Poseidon 2 itself, choosing proper hyperparameters, we actually did get 30-40% down. Then there is something which is called floor planning. This is somewhat technical. I mean, because since we've been working on a very low level, there is a thing which is called plonk table. So that's a thing where you actually can manually or semi-manually assign a particular part of the witness of the secret and write the constraints in a very raw mathematical form. So of course, like, this tables is enormous. It's not something that you can manually do. Although usually how it goes is that you have these constraints which are, you can think about them as shapes. So like each constraint that you need to that the proof needs to check has some kind of a shape, and then you need to fit them all into some table. So like this becomes kind of like a Tetris problem. So you've got like these various shapes and some amounts of these shapes, and you want to have a single table with it. So like you can do it gridly, or you can think about it how to put these shapes in order to gain something. So that was one of the other optimizations that we did. What else? I think like I think that's what's possible for the for the podcast format to explain. Although I recommend anyone to Google what can you Google Aleph Zero benchmark blog post. There is a pretty lengthy, quite technical blog post which describes one optimization after another, which shows this way from 10 to 1. Actually, we've been testing it our machines, and it was like 600 milliseconds, I think. So from this 10 to 600.
Yeah, Yeah, great, and really good to hear kind of all of the thinking that went behind making these decisions and deciding on the different optimizations. I think it's always good to hear like your thought processes behind it, and it's just like very insightful in general.
What's interesting here, maybe, sorry to cut in, is that the biggest optimizations were not this super deeply mathematical, but were more engineering related. So, like finding out how to properly run multi-threading in the side panel. Like, maybe because we are a team of mostly academics, and like side panels are much more of a black magic to us than the actual like moon math. But yeah, that's what we found out to be the harder part, actually.
Like the engineering design considerations. Got it. Yeah, I'm wondering just before we close up if there's any sort of takeaways that you want the audience to take away from, or like any sort of announcements you'd like to make. Just on the audience side, if you'd like to give them any advice as well, just some closing or last thoughts.
My thought would be that when it comes to privacy-related products in crypto, they're much more about user experience breakthroughs than mathematical breakthroughs.
Yeah, and just to add up on that, I'm really excited because for me, what we're building with the privacy tech is essentially one account, not wallet, but one account for your EVM assets, right? So that I can send coins to anyone without disclosing how much is in the wallet. We can invest in different projects without sending it to exchanges to break the trace. You can eventually also we're now aiming for Q1 with this, instead of having like privacy pools deployed on each chain, you can have more of a universal privacy pool for the entire EVM world. And this is just convenience. That's all it is, while sort of adhering to the principles of privacy as a human right. And it's pretty cool. So that's it.
And I really enjoyed in general, like both you guys providing the in-depth technicalities behind optimizing for the user experience, behind kind of the design choices that you made, and also at the same time providing like a overall broad scoped out vision that you have for the privacy landscape. So really liked that combo and really appreciate you guys for providing all the insights. Really happy to have you here today.
Thank you for having us. It was a really interesting conversation for us as well. I mean, for me at least. So thank you.
Yeah. Same here. Yeah. Thank you for your time as well.
Yeah, thank you so much.